Chapter 3, Periodic Table. Some elements like gold, silver, and iron have been known since antiquity. Scientists tried to understand the properties of the elements and attempted to arrange the known elements by properties in a table. In 1829, Johann Wolfgang Dobereiner grouped elements together with similar properties into groups of three, which he called triads. Lithium, sodium, and potassium was an example of a triad. However, elements within some triads did not have similar properties. In 1865, a British chemist, John Newlands, organized the known elements by increasing atomic mass, noting similar properties occurred every eighth note like a music scale, which he called octaves. However, Newlands did not postulate a solution when elements arranged by atomic mass were not like elements in the same family. Dmitry Mendeleev was a Russian chemist, and he published his version of the periodic table in 1869. Like Newlands, Mendeleev arranged the known elements of the time into vertical columns with similar properties by atomic mass. In contrast with Newlands, Mendeleev skipped a space in his table when the properties of the element did not fit the pattern of similar properties of other elements in the family. Not only did Mendeleev skip spaces for undiscovered elements, he predicted the properties of the unknown elements and, in many cases, how the element could be discovered. Mendeleev's accuracy in predicting the properties of the unknown elements and how they would be discovered earned him the title of Father of the Periodic Table. Rutherford conducted his famous gold foil experiment in 1909. After firing a beam of alpha particles, which are helium nuclei, at thin gold foil, Rutherford found most of the helium nuclei passed straight through the foil, indicating most of the atom was empty space. A few of the alpha particles were greatly deflected, which led Rutherford to conclude the nucleus of the atom contained positive particles. Today we know the positive particles in the nucleus as protons. The few alpha particles that were greatly deflected hit the positive particles in the nucleus. Following the example of Rutherford, in 1913 Henry Moseley fired a stream of X-rays, which are high-speed electrons at various elements. Thus, the contemporary periodic table today is ordered by increasing atomic number, which is the number of protons in the nucleus. When the contemporary periodic table of the elements is examined, not considering the latest discoveries of nanoscience, a pattern of repeating properties of elements is observed when the elements are arranged by atomic number, number of protons, in vertical columns. Elements with similar properties are arranged in groups or families, which are vertical columns in the periodic table. A group has a number and a family has a name. Horizontal rows on the periodic table are called periods, or series. The periodic law states many physical and chemical properties of elements tend to occur at regular intervals when the elements are arranged with increasing atomic number, which is the number of protons.